Isosceles Trapezoid. A couple of things about this guy. First of all, I'm going to go ahead and draw it to scale. There's a construction that goes with this, but it's kind of tough. I'm going to start out with 10 centimeters on the base. I'll put it over here. And now, I want to go at 45-degree angles. So what I can use my protractor to give me a 45-degree angle. It's about here. And on this side, I go from the other direction. I didn't do that up there. I should have. And I don't know what my sides are. There's some missing information here, and I'll show you what it is. This is 10 meters, and this one is 6 meters. Changed my mind on that. I know that this is 45 degrees. That's the important thing. Because if you know that both of these are 45 degrees, you know that these are equal. Because it's an isosceles trapezoid. A big part of geometry is making conclusions based on some information. Saul, what are you doing? We need this height, don't we? Right here. It's also the same over here, isn't it? You see that? I need to be able to find that height right there. And I happen to know that if this is 45 and this is 90, what's this angle up here? Right up here? Right there? That angle? This one's 45, this one's 90. What's that angle up there? Well, the whole angle is 135, but the little piece here is 45, isn't it? 45, 45, 90? This is an isosceles triangle right here. No, it's 45. 45 right here. Yeah, 45, 45, 90 right there. And this one is also a 45, 45, 90. Now the tricky part here is to understand what happens. Isn't this 6 meters right here? From here to here? Doesn't that make it 6 meters down here from here to here? So how much is each one of these? How much is this? And how much is this? 2. Exactly 2. Because this is 6, and isn't there 4 meters left? So that each one is 2 meters. So this is 2 meters. This is 2 meters. Guess what? This is an isosceles triangle. Isn't this one 2 meters? And this one's 2 meters? Got it? Now you can use Pythagorean Theorem to find the missing side here. You can get an estimate for this by using Pythagorean Theorem. Right there. That's your hypotenuse, isn't it? And this is a special right triangle where you have 2 equal sides and a 45 degrees angles, and you're missing the hypotenuse, and you can find it using Pythagorean Theorem. 2 squared plus 2 squared, and then take the square root. You're looking at the square root of 8. Isn't that almost 3? You know how I got that? Okay. If I want to find this missing side using Pythagorean Theorem, I can take 2 squared. A squared plus B squared equals C squared is my formula. I'm going to take A and B and substitute them in. And 4 plus 4 is C squared, so C squared equals 8. Is C equal to 8? Is this 8 right here? C squared is 8. What do I do? How do you find C if you know what C squared is? Square root. Got to take the square root of both sides. That means that C is exactly equal to the square root of 8 meters long. Now, I happen to know that that's about 2.8 or 2.9. Here's the way I know that. This thing is called interpolation. I know the square root of 4, don't I? What's that? 2. And I know the square root of 9. What's that? 3. So the square root of 8 has to be between those, doesn't it? Does that make sense to everybody? That the square root of 8 has to be in between these two? Which one is it closer to? It's closer to 9, isn't it? So is it going to be closer to 2 or closer to 3? Closer to 3. And isn't there 5 difference between these? Do you see that? Between 4 and 9, there's a difference of 5. And I'm 4/5 of the way down here. 4/5 is 0.8. That's where I get my approximately 2.8. If I grab a calculator, I'm going to get very, very close to 2.8. In fact, I'm going to get 2.848. 2.8 is almost perfect. So I'm going to use 2.8 is this distance, approximately. There's another way to go, though. If you memorize this special right triangle, remember I told you there's 2 special right triangles, 2 and 2, the hypotenuse is always 2 times the square root of 2. This is the exact distance right here. 2 root 2 is the exact distance. 2.8 is only approximate. So you can use either one for the perimeter and the area. You guys remember how to find the area of a trapezoid? I'm sorry? Well, we're going to talk about why. Right now, I'm just going to tell you that's what it is. It happens to be the reduced version of the square root of 8. Remember I taught you how to reduce radicals? C equals the square root of 8, which is the square root of 4 times 2, isn't it? Isn't that the square root of 4 times the square root of 2? What's the square root of 4? That's the exact answer. This is exact. That's approximate. 2.8 is approximate. The area of a trapezoid. One half base 1 plus base 2, you got to memorize it, times the height. But it's not hard to memorize it. In fact, I'll teach you where it comes from next time. When we start looking at trapezoids again, we'll see where this comes from. But you can get it off of your formula chart. It's better not to use the formula chart, though. You should know this one. After you use it a few times, you'll get better at it. Should I use 1/2 or 0.5?
0.5.
0.5 is better? Okay. Base 1, what's that? Okay, we'll use 10 for the base 1, plus the base 2, 6, times the height. Now the exact answer is 2. We're ready to go. We're fine. There we go. That's going to be 0.5 times 16 times 2, which happens to be 16 meters squared. That's the exact answer for the area of that trapezoid. Very easy. The perimeter is a little tougher. The perimeter, you have to add up the sides. Let me redraw it again. Sorry, it's kind of ugly, but there it is. Okay, this is 6, this is 10, and this is 2 root 2, and this one is 2 root 2, isn't it? Remember? Those are the sides, and you can add up. The perimeter is equal to side 1 plus side 2 plus side 3 plus side 4. All you do is add the sides to find the perimeter. And I've got 6 plus 10 plus 2 root 2 plus 2 root 2. And you can get an exact answer or an approximate answer for perimeter. Excuse me?
You have a problem?
I do.
Is Arden and Marvin here?
No.
Not this way?
Okay. All right, guys. Well, good luck. On number 3, finish this one, get the exact answer and the approximate answer. It's going to be 16, and we treat this like a variable, right? 2 root 2 and 2 root 2 makes 4 root 2. That's all you can do. You can't add these together. Now you can get an approximate answer for this if you substitute it in. For the regular hexagon and the isosceles right triangle, use the same idea. Remember on your regular hexagon,